Hi guys, this is Mr. Urrego. Welcome back to our Geometry OC review computer-based practice exam for the EOC. Alright, we're working on the official website for the EOC. Alright, couple things before we start. One thing, always check the description of videos, guys. I'm linking information, I'm linking more videos, I'm linking tools, anything that I think that will help you review for the EOC. Alright, one more thing. Guys, subscribe to the channel. Come on, 82% of the people that watch these videos, they haven't subscribed. If you guys subscribe, it's gonna help me a lot. All right, we need to reach more people. That's the idea. When you subscribe, YouTube is aware of that, and put the videos out there. That's the idea. All right, let's start. 31. The population of Florida in 2010 was 18,801,310, and the land was this. The population increased by 5%, 5.8 by 2014. So from 2010 to 2014, the population increased by 5%, 5.8%. Okay, so what's going on? So the nearest whole number, oh, let me erase this, what's going on with this thing? So the nearest whole number, what is the population density in people per square mile? Florida in 2014. So nearest whole number, how much did the population density in people per square mile increase from 2010 to 2014? All right, cool. Guys, density is nothing else than people over area. How many people in total, how many area in total. And that's going to give you the number of people per square mile in this case. All right, so let me show you something. So let's use some geography here. Let's say this is Florida, okay? And you're gonna have 18 million people here. 18 million people in Florida, okay? Density means in 1 square mile, let's pretend that that little square is 1 square mile, how many people we have there? All right, that's density. All right, now let's work on the problem. Let's do the math. So the first question is asking me the density in 2014. But the second question, they asked me from how much was the difference between 2010 and 2014 for the density. So let's find the density in 2010. Okay, 2010, I have 18,801,310 divided by the total area, which is 53,625 square miles. Let's do square mile definitely. Let's do miles square, and the top is people. So your density is going to be people over square mile. When I put this in calculator, let's get the calculator from here. Where's my calculator? Here we go. Calculator is, this one is the calculator. All right, I got my calculator. So my calculator is going to be 18. All right, 18,801,310 divided by 53,625. Oh, come on. 18,801,310. Okay, for some reason it's not showing me the zero. I don't know why. Okay, I just moved the calculator and it worked now. All right, so it just, I don't know, for some reason it wasn't showing. So 18 million, that divided by 53,000, my answer is 350. So my density in 2010 was 350. Let's use a couple of decimals. 607, so let's just round it to 61. And this is people per square mile. So put mile to the second power. All right, that's 2010. Let's do the same thing for 2014. Now, the problem says that in 2014, my population grew by 5.8%. All right, 5.8%. So I gotta find out what's my population here. So if this is the 100%, then what I need to do is increase that population by 5.8%. All right. So the way we're going to do this in the calculator is I want to use the calculator as much as I can. So this is my population in 2010. I'm going to find out what was the increment, 5.8%. So what I'm going to do is I'm going to multiply, because I don't see a percentage here. on this thing. So I'm going to do times 5.8%. Means you divide by 100. So 5.8 divided by 100. And this is the increment. This is the increase. This is the how much population, how many people increase from 2010 to 2014. So let's write down over here. So my increase, this is not the whole population. This is just how many people increase. And 1 on 90, 475, 475.98. This is almost one person. So let's just write those two decimals, okay? And this is the increment, 1 million people. Then I'm going to add how much I had in the original, which is 18 million, right? 801, 310, and that's the total people in 2014. So I'm going to add these two numbers. Again, how can I do this on the calculator? All right. Let me get this thing here. Okay. And I'm going to add. All right. So this is the 5.8%. I'm going to add my original, which is 18 million, 801, 310. So my total people in 2014 was 19,891. 785.98. All right. Where's my decimal? Okay, 0.98. 0.98 is one person. You know, I can round it. So to find my density, I'm gonna divide it by the area, which is the same thing because Florida didn't grow on that time, right? Obviously, the land doesn't change. So I have that now. Okay. And I'm gonna bring that over here, and that's gonna be equal to, oh man, my answer. Okay, enter somewhere. No, this is degrees, clear. Okay, I guess I'm gonna clear this out, which doesn't work for some reason. Okay, so again, work on the calculator. Getting familiar with the calculator because as you can see, it's kind of annoying. 891. 891, 785. Good thing that I'm writing all my numbers. So 0.98 divided by my land, which is 53,625. And whatever I get, this will be the density in 2014. So my density is going to be 370.94. 370.94 people per square mile. Okay. All right. I don't think I need to calculate anymore, so you're gone. So let's read the problem. So the nearest whole number, what is the population density in people per square mile in 2014? To the nearest whole number. So that means they want me to round. So that 370.94, I need to round it to 371. That's answer number one. Okay. What am answer number two? To the nearest whole number, how much did the population density in people increase from 2010 to 2014? In 2010, it was 350. In 2014, it was 370, right? So, and it says to the nearest whole number, 350. If I round it here, it's going to be 351. If I round it here, it's 371. Anyway, 371 minus 351 is 20. So 20 people increase. And that's 31. Nice problem. Let's go 32. 32, let's read. The Leaning Tower of Pisa is 56.84 meters long. Again, that's how long the building is. It's not the height because this is leaning. So you see this diagonal? All right, so that's how long the building is. In the 90s, engineers restored the building so the angle Y changed from 5.5 to 3.99. Angle Y is this little angle at the top. So before it was bigger, now it's smaller. So technically they made it straighter. All right, so they push it up. Okay, interesting. To a nearest hundredth of a meter, how much did the restoration change the height of the Leaning Tower of Pisa? All right, so we have to make two joints. All right, here are going to be the two joints. So I have my joints right here. Okay, I got my two triangles. So this is the height of the building, the diagonal, because it's leaning. And here, 56.84, again, this is the building itself. They're asking me for the height, vertical line, right? Straight up and straight up. If you notice, I made this angle a little bigger than this one so you can visualize what's going on. So what do I need to do? I need to find the value of H1 in this case. Remember, they're asking me for the restoration. So what's the restoration? Restoration is basically the difference between the origin, not the original, you know, when the tower is much straighter, minus the original. So you want to know how much was the difference in heights. So how do we find this measure? Then we're going to use some trig over here, trig. And we're going to use so, ka, do, a. What is this? Sine, cosine, and tangent. You got to remember this thing. Sine, cosine, and tangent. What is the O, the H stands for? Opposite side over hypotenuse. What is the A? Adjacent side, H, hypotenuse. O, always opposite. A, always adjacent. All right? So I need to find out when I use sine, cosine, or tangent. It depends what I have. Here's my angle. All right? This is a right angle. This is a right angle. You notice they give me the right angle. So this long segment is always my hypotenuse. Okay? This long segment is my hypotenuse because it's across the 90 degrees. Now, the H1, is it adjacent or opposite to 5.5? Opposite is across, so this will be opposite, which I don't have. I have adjacent. So this side is adjacent. Therefore, I have hypotenuse and adjacent. Hypotenuse here, adjacent now, adjacent hypotenuse. Here we go. I'm going to use cosine because tangent is opposite or adjacent. So I don't need this, I don't need this. I'm going to use cosine because adjacent over hypotenuse. Okay, let's start. Let's flip colors. So I'm going to use cosine of 5.5, which is my angle. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Okay, cosine of 5.5. What's adjacent? If this is the angle, adjacent is my side that is next to it, which is H1. Over hypotenuse. What was hypotenuse? Across the 90-degree angle, which is 56.84. All right, now I have to leave the H1 by itself. That means I got to cancel the 56. How do I cancel something that is multiplying? Yeah, I'm sorry, something that is dividing. I multiply on both sides by the same number. I multiply 56.84 and by 56.84 on both sides. All right, I'm multiplying both sides. What happens is division, those two cancels out, and on the right side I have H1. On the left side I have, let's get some space. It was too tight. Okay, so let's make a line over here. All right, so H1 equals 56.84. 56.84 times cosine of 55. All right, I'm gonna put that in calculator. H1, let's get rid of this. Where's my calculator? Oh, I need this. Calculator is this one. And what we're doing is 56.84 times cosine of 55. 56.84, all right, times, where's my cosine? Cosine of 55 degrees. All right, make sure you had, look at this. Let me bring the calculator on the one side. Okay, 56.84. 56.84 times cosine of 55. Make sure you have these degrees, all right? You don't have radians. Make sure you degrees, okay? Because that's what we're working on, degrees, all right? Make sure it's highlighted. And my answer is 32.56. Hold on. 56. Oh, I put 55. It's 5.5. Ah, you see a mistake? Holy cow. It's 5.5. I almost messed it up. I know some of you are screaming, no, it's not 55, it's 5.5. Thank you for letting me know. I got your message. So let's go back over here, and we says cosine of 5 point. Oh, let's get into the calculator. 5.5. There we go. So let me double check. 56.84 times cosine of 5.5, and my answer is 56. And let's use like 3 or 4 decimals. 56, 57, 83. 56, 57, 83. Okay, and there's more decimals, by the way. I'm just going to keep those 3 for now. Those 4 for now. Let's use the same process on the other side. Okay, so let's use red. So cosine of 3.9. I want to make sure that I see that dot. Is equal to cosine is equal to adjacent over hypotenuse. Adjacent is h2 over hypotenuse, which is 5684. I got to cancel the 56, so I got to multiply on both sides. So I'm going to have 5684. I'm using the same process, right? I'm multiplying on both sides. Times cosine of 399 is going to be me h2, right? 5684 cosine of 399, same thing. That means h2 is 5684 cosine of 399. So let me go back to my calculator here. 5684, and now instead of 5.5, I'm going to change my angle for 3.99. All right, and my answer is 56. And again, I'm writing 4 decimals, 7022. 7022. All right, there's more decimals. And the reason I'm doing that is because look at this. See how similar those two numbers are. 56, 57, 83, 56, 7. All right, so this tiny the difference. Now the restoration, I said that's going to be the new one minus the old one. So restoration is going to be the new one, 56, 70, 22 minus the old one. You want to see how much you improve. 83, right? So I have the new one right there. So again, I don't know how to do this to put the answer right there. So let me erase a little bit. So let's get rid of all this. And now I have my two numbers, 56, 70, 22 minus 56, 57, 83. All right, so my difference, my restoration is 0.012. They're asking me to the nearest hundredth of a meter, how much did the restoration change the height of the Leaning Tower? Nearest hundred, so look at this, I have 0.1239. I need to run to 2 decimal places. The next one is a 3, so that means when I round that number, it stays at 0.12, and I had to do this, approximate equal to 0.12, and that's my answer. So let's pull this up, let's put our answer and move on. Cross 0.12, 0.12, okay, that or 0.12, one of the two, I believe either one, it will be made the same. Let's go to 33. All right, we got 33 now. We have a drawing here, triangles B are shown where angle B. Okay, so let's label that right away so we can see the information. Whatever they give you here, you always put it in a drawing. Angle B congruent to angle D. Angle B congruent to angle D. Okay, what else? Angle KT. So let's put double arc here on T and double arc on K. All right. BK DT. BK. Oh, okay. So on this side is equal to this side. All right. So technically that's angle side angle. Angle side angle, and here's angle side angle. So those triangles are congruent. All right, cool. So let's read the problem and see what it says. This question has 3 parts. Rashid performs the sequence transformations on triangle BKW to map it to R. So this is the pre-image, this is the image because it's going from here to here, and this is different possible transformations. Okay. Part B. Coordinate grid shows 3 triangles. That could be an intermediate step for Rashid sequence of transformations. Use the arrow tool. Oh, nice. Arrow tool. Where's the arrow tool? Here's the arrow tool. I'm assuming. Oh, we can make arrows. All right, cool. To show the translation for part A, then label transform triangle by dragging B prime. All right, so, okay, cool. Next. Once you justify those angles are congruent and that the segments are congruent are sufficient to show that triangles are congruent, yes, they're sufficient, angle, side angle. Select word or phrases to complete Rashid justification. All right, we complete that. So let's do one at a time. All right, so first part is A. There we go. Which sequence transformations could be used to map this BK into DTM? So we gotta do one at a time. All right. Let's do the first one. A. All right. So let's consider the first one. A. A translation of up 8 and a reflection across the y-axis. So I'm going up 8. All right. And a reflection across the y-axis. You have to remember something. B is congruent to D. So if I do a transformation, I have to do a sequence, and I'm trying to map this triangle into this triangle, that means B will end up at D. K will end up at T. And therefore the third angle, which is W, will end up at M. So I just need to take one of those. Let's take B. I'm going to go up 8. So if it's at -1, I go -1. That's 1 step to the axis and 7 up. Right? I'm going up 8. This is B. And then it says reflection across the y-axis. If you do reflection across the y-axis, then I'm going 1, 2, 3, 4 steps here, and that means I'm going to go 4 steps on the other side. 1, 2, 3, 4 steps. And this should be D. All right, remember, B is congruent to D, and is not. Therefore, the first one is wrong. You don't need to do the whole thing. You just take in one point, and when that point coincides, then you check the other ones. All right, let's check B. B. A translation of left 10. 10 to the left. And a reflection across the x-axis. So let's take B again. And I go 10. So from here, I'm at 4 right now. So it's 4 and 6 is 10. And here, I want to go straight. So here is B. All right. And then it says a reflection across the x-axis. How many steps from here to the x-axis? Only 1 step. That means I'm going to go 1 step to the other side, and here should be B, which is technically D, all right? And that is not the case. 10 to the left, and then across the x-axis. If I went 1 step to the x-axis, then to the other side is 1 step. And here should be B, which is not, therefore that's wrong as well. Let's check the third one. A translation of left 10 and up 4. So I'm going to go 10 from 4 to all the way to -6, right? And then it says up 4. So 1, 2, 3, hold on. 1, 2, 3, and 4, all right there. Okay, then a reflection across the line y equals 3. This is 3, so the line will be this line. Reflection across that line. Okay, so my point D, okay, this is interesting because right now B, when I went 10 to the left and then I went 4 up, is right there. So B is correct. Okay, so let's draw this triangle. So this is D, all right, so this is 1, 2, 3. Let me draw the triangle. 1, 2, 3, 3 to the right, 1, 2, 3, and 1 down. And then point W is going 1, 2, 3, 4, and 2 to the right. 1, 2, 3, 4, and 2 to the right. And this is point W. All right, so this is my triangle before I reflect it. Okay, that's my triangle. And remember, this is W, and this is K. Okay, but K is going to be T at the end, and this is B, which turns into D, and this is working right now. Now they're saying a reflection across the Y equals 3. So a reflection is this. All right. B is not moving. All right. K is 1 away from the axis, 1 away from the axis. This is right there. Excellent. What about W? 1, 2, 3, 4 steps all the way to Y equals 3, right? This is the line Y equals 3. So W, 1, 2, 3, 4. Now to the other side. 1, 2, 3, and 4. And E coincides with M. My answer is C. Excellent. Translation of 8 up and reflection across the line. That's my answer. I don't need to move ahead, but let me get a translation of 8 up. 8 up. I want to move this triangle 8 up. And across the line that passes through the origin and B prime. Origin and B prime. We don't have B prime. So no, my answer is B. I'm sorry, C. Here we go. And now let's work on part B. Okay, so let's erase part B. Here we go. The coordinate grid below shows steps to triangles that could be an intermediate step of a sequence of transformations. Oh my god. Okay. Alright, so I could have saved time if I checked this. Look at this. This is the translation to the left, then this is the translation up, and here's the reflection. Okay. Alright. I didn't check that. So make sure you guys do you do, alright? So you make my mistake. Let me erase whatever I did here. Alright. Erase. You hit the delete. Add arrow. Use the add arrow tool to map the vertices of BKW to show the translations chosen in part A. Okay, so that means, if I'm not mistaken, I went from here to here, K went from here to here, and W went from here to here. And this is when we move, how much we move to the left? 10 to the left. And now we gotta move 4 up. So this point, arrow, is gonna go 4 up, straight up. At this point, which is K, move straight up here. And this point W is gonna move straight up here. I'm assuming those are the arrows that they want. Use the arrow to map the vertices of triangle, yes, to show the translations. Translations, I'm moving to the left and then I move up. Those are translations. Then label the transformed triangle by dragging B prime. Okay, so now I gotta label this triangle using the primes. Okay, this is B. This is B. And this is B. Alright, B prime. So I'm gonna grab this and I'm gonna put it right there. Now let's go with K. K is the one on the right, the one on the right, the one on the right. This is K. So K prime is right there. W, the bottom, the bottom, the bottom. So let me bring W somehow and put it right there. Alright, we label the correct vertex. Great. Let's go. Part C. Rashi wants to justify the angle B, okay, are sufficient to show that triangles are congruent. Okay, that's fine. By translating triangle, select the words. By translating triangle, triangle BKW, so B maps into B prime, then B coincides. All right. So, same thing that we did in the first part. Okay, B is going to coincide with D on the new triangle. So then B prime coincides with D. All right. Remember, K prime, when it's reflected, is going to be T. So K prime coincides with T. And then W prime, when it gets flipped, is going to be M. And W coincides with M. All right, cool. Because the definition of what? A mapping function, equivalence of transformations, congruent in terms of, hold on, because the definition of something like this preserves distance and angles. Oh, what preserves distance and angles? Congruence of rigid motions. Rigid motions. Rigid means I'm not changing the size of this triangle. I moved it to the left, same shape, same size. Look at this, I didn't change, I didn't dilate it. That's what the rigid motion means, okay? Preserves distance and angles, yes. Any translation stays the same. The triangle stays the same, all the angles the same, the size the same. Okay, that's what they're saying. Distances and angles. Then triangle BKW is congruent to triangle. Oh, here we go. I believe we need to the order. Okay, what's the order? Okay, BKW. All right, so look at this. All right, it's the order. BKW triangle is congruent to what? B is the same as D, right? So I got to, if I start in B, then my second triangle starts at D, right? K is T. So my second letter is K. Then we're here, the second letter has to be T because K is congruent to T. K and T are congruent. Remember that. And the third angle was W with M. So W is the third letter, my M will be the third letter. So my order is DTM. DTM. Erase, move down, DTM. And we're done. Excellent. Last question, 34. Woohoo! Alright, so let's read this problem. Let's see what we have on the left side. Natasha's classmates have ordered her a cookie pizza for her birthday celebration. To share it among the class, they will be slicing the cookie into equal pieces. They want everyone to have an icing packet to add to his or her slice. In order to approximate how much icing each person will need, they want to know the area of each slice of the cookie. The following table lists the radius of the cookie and the area of some of the possible divisions of the cookie. Okay, so let's look at the table. The whole cookie is 360, obviously, because it's the whole circle. Okay, so the whole cookie is the whole circle. All right, so let's get a pencil. So this is the whole cookie. The radius is 6, all right? The radius is 6. And the area is 36 pi. All right, why is 36 pi? Because if the radius is 6, remember, the area of the circle is pi r squared. If the radius is 6, I need r squared. R squared is 36. Therefore, I have pi times 36, and I want to organize, I want to put the number in front of it, so area is 36 pi. And that's the area of the whole cookie. And these are possible divisions. If I divide the cookie in 2, then my degree, my angle, obviously, is only half, which is 180 degrees. And the area is half of 36, which is 18. If I divide it into 4 pieces, then each angle is going to be 90, right? 90, 90, 90, 90. And I divide the area, 36 divided by 4 equals 9. And the last one, 1/8. All right, so let's go for the questions. We understand the problem now. Let's go for the questions. So the questions are the following. Question has 3 parts. Part A. What is the relationship between the area of the whole cookie with the radius of 6 and the area of a portion whose central angle is K degrees? All right, that's interesting. We'll check that in a minute. Using the information in the table, click in the blank to complete the equation for finding the area of a portion of a cookie with radius of 6 when given the measure of a central angle. Okay, so guys, let me just real quick address this one. If this is the cookie, and I said let's divide it into 4 pieces, and I want only one piece, this is called a sector. So what they want here is the area of a sector. And again, I've been saying throughout my videos, make sure you get used to the equation editor. This is the equation editor, I believe. How to input those equations. Okay, make sure you get used to it. All right, let's close that. So here we're gonna write the formula for the area of a sector. Okay, part C. Click on the blank to complete the formula that can be used to find the area of any portion of a circle with radius W and a central angle of Z. I use the same formula, I just replace the radius and the central angle for Z. Got it. Okay, we're good. Let's start. The first part is interesting though. Okay, because we're talking about sectors right now. That's what we're doing. Let me scroll up. So what is the relation between the area of a whole cookie with the radius of 6 units and the area of portion? So we need to understand what's going on in here. All right, we need to understand the relationship. They're saying what is the relationship between the area of the whole cookie, okay, and the area of a portion whose central angle is K. So for that, I just want to look at the table and see what the relationship is. So let's say 36. So my area is 36 pi, right? That's the whole thing. Now, how from here, how do we end up having 18 pi? How do I get 9 pi? How do I get 4.5 pi? All right, that is the question. And that area has to be linked to the measure of the central angle. Okay, that's going to solve a question. Let me just show you something real quick. Area of a sector is the area of a circle, which is pi r squared, times central angle divided by 360. Okay, that is the formula that I have to put in here. This is the sector. They're saying, what is the relationship between the area of the whole cookie, that's the area of a circle, this, and the area of a portion. So what they want is this ratio. What is this? Okay, so what is this? How do I get up to 18 pi? How did I get to 18 pi? Look at this. Central angle over 360. Let's do this. 18 pi. Central angle. What's central angle? 180. Over 360. How much is 180 divided by 360? That's 1/2. If I divide it by 180 on the top and then by 180 on the bottom, I get 1/2. That's how I get the 1/2. How much is 1/2 of 36 pi? How much is 36 divided by 2? 18 pi. That's how I end up with 18. So this is the relationship that they want. What relationship? Central angle over 360. That's the relationship they want. Okay, let's go back to the problem. What is so my relationship is central angle over 360. What is the angle that is given on part A? Whose central angle measures K. So the relationship is K over 360. Central angle of 360. Answer is C. There we go. Interesting though. That's a interesting problem. Okay, let's go to part B. Now on part B we have to write the answers. Okay, so let's erase real quick. Let's keep the area of the sector and let's scroll down. Okay, using the information in the table, click on the blank to complete the equation for finding the area of a portion of a cookie. Portion of a cookie is sector with a radius of 6 units when given the measure of central angle in degrees of the portion. Okay, so let's scroll this out. Here we go. I have my equation editor on the bottom. Let's erase whatever I have to erase. Okay, let's erase this thing so it doesn't bother me. And let's get the equation editor. Here we go. Let's get the equation editor. Okay, so I'm doing part B. What is the equation? Using the information in the table, click on the blank to complete the equation for finding the area of a portion. So, okay, it doesn't let me do both things at a time. So area of the sector is equal to pi r squared. But they want the radius to be 6. So I have to plug in here 6 squared, and 6 squared is 36 times pi is going to give me 36 pi. When given the measure of central angle in degrees of a portion, what's my angle? I have no idea. They're not saying the angle. So I'm going to use the K that I just did over 360 degrees. So this is the formula of the sector that I want to key in. You can put the K, you can put an X, you can put whatever, because I don't have no idea. Look, when given the measure of a central angle, I have no idea the angle. So you put a variable. I'm using the K because they just use the K. You can put an X, you can put any variable, I believe. Okay. All right, so let's key in that answer. Let's get the question editor. So let's see what's going to open. Okay, here we go. So that's my part B. So this is what I want to key in. So let's start 36 pi. So 36 and the pi is going to be over here on the right side. I'm going to put it times, I guess, here times. I need a fraction because I'm going to put k over 360 fraction here. And I need a variable. Oh, here's the k. Oh, okay. So they meant, you see there's no more variables here? Interesting. So k divided by, go with the arrow, 360. Interesting. So they wanted me to put the k as a, so that's my formula. All right, so that's B, part B. Let's go with part C. Click on the blank to complete the formula that can be used to find the area of any portion of the circle with a radius W. Okay, so radius W and central angle of Z. So I have my formula here. Make sure you have your notes right. Piece of paper, scratch paper. And I'm going to key in, I'm going to key, okay, come here. I'm going to click that, all right. And I'm going to put this formula, but instead of the radius R, I'm going to put a W. So I'm going to key pi, all right. Oh, look at this. They give me W and Z, so okay. And instead of the RW, the radius is W. So I'm going to put W, and I need to do this thing. No, not yet, not yet, not yet. Okay, so pi, W, and with the W I put the exponent. There you go, to the second power. And I move with my arrow to the right to make sure that I'm not in the exponent. And now times central angle 360. But what's the central angle? Z. So I need a fraction on the bottom, fraction. On the top is central angle. In this case is Z. So, and they gave me the Z, nice. My arrow down, 360. And I am done. Me see 34. Woohoo! Done. Excellent. Alright guys, so here we go. We're done. We're finished. I believe so. Hold on, let me see. Let me clear all this. Let me see. We hit next. Alright, so when you hit next, same thing as section 1. You're gonna see all those triangles means questions that I missed. But remember, this video I was doing 31 to 34. So let me show you something. Where's that? Where's that? Let me get rid of this. And test. Oh, okay. So you can go to question 20. You can go to question 22. Okay, and scroll and go answer whatever you're missing. If you flag it, then it's gonna have an arrow right there. Okay, what I'm gonna say is I'm gonna link to the bottom a series of videos that I did. It's called Beat the Test. It's another practice exam. Amazing, actually. And I got it from the same people from the EOC, and they have a lot of videos about Algebra Nation. Okay, same thing as in this test. This test has several problems from Man Nation because I'm familiar with Man Nation. So I'm gonna link that on the bottom, on the description. Okay. All right, guys, I'm gonna put as many tools as I can on the description of these videos and every single video for the EOC. Make sure you check the whole library for the EOC review for geometry and Algebra 1, just in case you didn't pass the Algebra 1. I'm gonna put a lot of material for Algebra 1 as well. And check also Beat the Test. Let me see if I have one over here. Beat the Test. Beat the Test. Here we go. Beat the Test. Here's question 43. Let me just scroll down. Let me show you real quick. the series that I'm showing, that I'm talking about. Okay, I'm changing the, here we go. This is the first video. All right. So I'm gonna link that on the description. Here we go. Okay, and it's called question 1 to 3 be the test. I'm gonna put the link underneath, and that's a great video to check. Serious. All right. So make sure you check that series and subscribe to the channel. I'll be putting more videos for the EOC. The idea is to get you prepared for the end of course exam for Algebra 1 and Geometry, just in case you didn't pass the Algebra 1. Alright guys, again, like the video, subscribe to the channel. I'm going to put a video there, right there, for suggestion for you to click so you can keep going reviewing, and click the notification bell so you can get notified when I upload more videos. Alright guys, thank you for watching. Take care. Have a good one. Bye-bye.